Okay, this is the problem we're going to work on. This is sample problem 3C from your book. Hiker walks 2.5 kilometers from her base camp at 35 south of east. On the second day, she walks 41 kilometers in a direction 65 degrees north of east, at which point she discovers the forest ranger's tower. Determine the magnitude and direction of her resultant displacement between base camp and the tower. Ugh, that's hideous. So it's hideous on multiple grounds. Let's start off with a what? So she starts off 35 south of east. Always start with little compass rose on these. And you're going to draw these every time you turn because that gives you a good sense. So, you know, we know that that would be 45. We want to be a little bit above 45, so we'll do that. And that would be 35 degrees south of east. She goes 25.5 kilometers. That's her first displacement. Then, day 2, presumably she makes camp. I'm going to draw another little compass rose at the end of that vector because now she's going to walk 65 north of east. So there's 45. I want her to come back like this. And this is 65 degrees. D2 is 41.0. Okay, so now I can get rid of this. And what I have is this lovely little beast. What do I want? I want that. So where are my two triangles? Well, I've got that, and I've got that. Okay, it's not so bad. Because where's my overall triangle? It's easy to see the individual ones. My overall is there and there. Okay. So let me undo some of the pretty colored lines. I'm going to start off with what I always start off with, right up here. Resultant equals the square root of delta x total plus delta y total. And I'm going to write up here that delta x total is going to equal delta x1 plus delta x2, and delta y total will equal delta y1 plus delta y2. These aren't so bad if you just break them down. So I'm going to deal with that first displacement first. Now the angle, this is the other potential pitfall. Could you use the complement here? Yeah, you could. You could draw your angle outside there. You can use either of those triangles. My tendency, unless it's really hard to do that, unless it's really in a position where you can't clearly define it, my tendency is to use the triangle that is defined by the angle you were given. It's one of those things where it's just one less mistake for me to make. So this is delta x1, this is delta y1. And when I can, I do like to label those because, again, it's one less thing that I can screw up. Okay, so let's get some math attached to those. I can see that y1 is opposite my angle here. So I know, therefore, that I'm going to use sine, and sine theta will be equal to delta y1 over d1 So sine theta times d1 will give me delta y1. Sine of 35 times 25.5 kilometers equals delta y1. What's my raw number? Okay, so I've got my delta y1, 14.26 kilometers. And, you know, if you were drawing this large enough, it might do you some good to actually put that in your picture. Here, I don't feel like I have room to do that without just muddling up the picture, so I'm not going to. But it can be helpful. So I'm going to shrink all this. I'm going to circle this intermediate answer here, because that will help me later. I'm going to shrink this down a little bit. And I know that cosine theta will equal delta x1 over d1. Cosine theta d1 equals delta x1. Cosine of 35 times 25.5 kilometers equals delta x1. Okay, so I get a raw answer of 20.88, etc., kilometers for delta x1. So I've got my two pieces. Oh, what did I forget to do here? And this is really important, especially in this case. We know that delta x1 is traveling east. Delta y1 is traveling south. And that's going to become really important here. So I'm putting in my little arrows. Again, I'm a visual learner. And so that tends to do well for me. You can also put in east and south. Make sure you indicate to yourself which direction those are going. It's going to help. Okay, so let's tackle the second displacement. Again, whenever possible, I use the triangle that would be governed by the angle I was given, which would be out here using that 65. And I'm going to label these. Let me see if I can get a darker green. That might be better to read. So this would be delta y2. This would be delta x2. And right off the bat, what do you notice about delta y2? It's north. It's going in the opposite direction of delta y1. So we're going to have to consider those signs when we add those. Okay. D2 it is. So looking at my angle, once again, y is opposite my angle. So I know that sine theta d2 will give me delta y2. Notice that I skipped a step there. Once you're comfortable with these, you don't need to write out sine equals delta y2 over d2, because you're just going to know that you can solve for delta y2 that way. It's perfectly acceptable to start here. However, if you find that you're screwing it up, start back a step. This is one of those steps that you'd learn to skip, but you should start off not skipping. Okay, so therefore, sine of 65 degrees times, she hiked, what, 41 kilometers? That's a heck of a day. Equals delta y2. What's my raw answer? Okay, so I've got 37.158, on and on and on, etc. North is my delta y2. I'm going to shrink that up a little bit. And again, I'm going to start, because I know that delta x2 is adjacent to that angle. So cosine theta times d2 will give me delta x2. Cosine of 65 degrees times 41.0 kilometers equals delta x2. I have 17.327, etc. kilometers. East is my delta x2. So now I've got all the pieces I need to find these. So if I was working on a regular piece of paper, this is where I would have probably started working down the side with my delta x total, delta y total. So I'll just go ahead and do that. Oops. I'll move that label inside the triangle. Okay, so delta x total equals, well, delta x1 was my 20.88 blah 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 km east plus delta x2 was 17 point something 32 blah blah kilometers also to the east. What's my delta x? Okay, so I've got my delta x total. It's 38.215, etc. It's to the east. I've put my arrow in there. Now comes the one that's got a little trick to it. So delta y total equals delta y1 plus delta y2. But the situation we have is that, whoops, they're in opposite directions. That one is south, that one is north. So the easiest way to handle that is to assign signs based on a Cartesian coordinate system where north is positive and south is negative. Here's your other option. Your other option is to look at your values, and in this case, it would give you the same result. See which one's basically the larger number, so that you're dealing with positive numbers. Like I said, either one is valid, and in this case they would give you the same result because our northward displacement is larger than our southward displacement. But just keep in mind that as we go through these, that is an option. Okay, so delta y total equals, well, we've got 14, I'm going to put a negative here, 14.62 blah blah kilometers plus the 17. Let me see if I can shrink this anymore. $17.327. And obviously you can turn these around and just subtract the 14 from the 14.62. Right now I'm just doing this to keep my delta y1, delta y2 lined up. So let's get a raw number. Hey, that's why a few of you had crinkly brows. Yeah. Hey, I screwed up. That's a pretty common kind of mistake. So let me fix that. Yes, I put my delta x2 in instead of my delta y2. 37.158 blah blah blah. And of course this one is south, this one is north. Okay, that's better. Now let's get a raw value for that. Okay, I get a raw value of 22.53 and it just keeps going north. Is that what you're getting? Since I've already screwed this up once, you might want to check me. Okay. All right. Oh my gosh, it seems like we should be done. This is so much work. We're not done. We're not done, I'm sorry. Because what we really want is this overall. Because that's what we're going for. So it's sometimes helpful, especially with these if they've gotten really messy. I will sometimes come over here and redraw my overall triangle with labels. So I know my delta x1, that 38.215, etc. east is there. And my 22, this doesn't seem right, but I'm going to just have faith that it'll all work out in the end. 22.53 blah 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 north is there. So what's my resultant? Well, you know, R equals. Because I'm not trusting how the calculator is handling scientific notation. Are you getting 44.363 kilometers? Okay. Are we done? No! drop a brick on my toe now. Aren't these fun? You still have to find the heading. So for heading, this is where this really helps me. My delta y is my opposite. My delta x is my adjacent. Okay, so I've written out that the inverse tangent of delta y total over delta x total equals theta. Let's get some actual numbers. We only have 10 seconds. We're clearly not going to finish this. So you finish this on your own. Obviously, the answer's in the book. It's not like it's a test, but assigned are all of the 3C, and we will spend time tomorrow working on them, but I want you to have at least done one of them on your own before then. So 3C problems, all of them assigned, get at least one of them done. That's it.